Welcome to Pindar Poetry. We hope you learned something new.
You start by verifying the GPU and installing drivers now. Check the model, then install the matching NVIDIA driver and CUDA toolkit so libraries align. Once done, add cuDNN that matches CUDA, reboot the machine, and run NVIDIA SMI to confirm the GPU is visible. Make sure drivers and CUDA versions match your deep learning frameworks. Mismatches cause runtime errors. While you do that, prepare a clean Python environment so dependencies won't conflict. Next, create an isolated environment and install GPU-enabled framework builds, TensorFlow or PyTorch compiled for your CUDA version. Install Jupyter Lab or Notebook inside that same environment, then add ipykernel and register the kernel so Jupyter uses this environment. Once started, set CUDA visible devices to control which GPU is used. Then run quick checks like torch. CUDA is available, or TensorFlow's GPU device listing to confirm Jupyter can see and allocate the GPU. If tests pass, you're finish by running a realistic, small GPU workload and watching NVIDIA SMI for memory and utilization to ensure proper execution. If you see no GPU usage, check that the notebook kernel matches your GPU-enabled environment and that CUDA and cuDNN versions align with the framework. One key troubleshooting step. If errors persist, reinstall the exact matching CUDA and cuDNN versions, update the notebook kernel spec, restart Jupyter and the NVIDIA driver, then retest. This sequence resolves most compatibility issues quickly.
Thanks for watching. Consider subscribing if we helped you.